Okay, let's start with our exercise 6. Okay, now this is what we call one hot encoding. Now this is actually a programming algorithm. Okay, it is used in many applications. Okay, so let's take a look what it actually means. So you have an array like x is equals to 3102, that is actually provided to you, and your output actually looks like kind of like this. Okay, so what is the relation between this input and output? Okay, let's try to understand that first. So first of all, you can see the number of columns in y is 4 and the number of elements in x is also 4. If you take a look at this another example, number of elements in x is 5 and the number of column in y is 5. So that is actually first relation. The number of elements in x is equals to number of columns in y. Okay, now the second relation is the number of rows in y will be equals to the maximum element in x, the maximum element is x, okay, plus 1. So since the maximum element is here 3, so plus 1, that means 4. So since there are 4 rows, okay, now why is that? Okay, let's try to understand. So this this is actually a what we call a logical array, because there is only 0 and 1. You have already, I believe you have already experienced lots of logical arrays. So this is actually a logical array. So it is providing 0, that means false for all the other things, only providing true for only one of the element in each column. In each column you have only one. Okay, you have only one true. Okay, so that is actually the relation between these things, one to one relation. So let's see, when I have 3, the last element in the first column is actually 1. When I have 1, the second element is 1, all the others are 0. When you have 0, only the first element is 1, all the others are 0. So it is like a one-to-one relation. Okay, let's take a look at another one. So since it is 0, that means the first element is 1. Again it is 0, the first element of the second column is 1. Then in the third column, so 1, it is 1. So 1 plus 1, so the second element, okay, the second element in the third column is 1. Again 0 1, so 3, that means the fourth element is 1. So this is actually like a one-to-one relation between the x to 1, x to y. I am representing this vector x, okay, in terms of a logical array. I am representing this vector x using a logical array. Okay, so this is how we are actually representing this thing. And the question is how to actually do that, how to write a program to do that by yourselves. Okay, so we are asked to actually create a function named one hot encoding. Okay, let's just copy this down. Copy. Okay, now let's place it here. You already know how to write a function, user defined function. So function, so this is our output y, and the name is one hot encoding, and we'll take x as the input, and both this x and y, these are local variables, not global variables. Okay, let's save it. And why we save it, the name should be the same as the file name. Okay, the file name and the function name should be same. Now let's write our function. So let's copy the input first. So this is our input. So x is equals to 3. So we actually let's create a zero matrix. If you remember from your last week's lecture, we have a built-in function called zeros that can actually do this task. Okay, so for example, if I write zeros of, okay, 3 comma 6, it will create a 3 by 6 matrix all with zeros. Okay, now 3 is the number of rows and 6 is the number of columns. So in this case, okay, in this case the number of rows will be the maximum element of x plus 1. So let's create a vector, let's create a to define a variable now. Row is equals to maximum of x plus 1. Okay, so this is our number of rows. Okay, let's create another variable called column. It should be the number of elements in x. So it is like numeral of x. If you remember from these two functions were introduced in the last week's lecture. Okay, so now we have two variables, row and column. Both are local variable only within this function. Okay, now so I will create a matrix like y is equals to a zero matrix, matrix of zeros, the number of row and number of column. Okay, so let's do this and let's end this. Okay, so if we actually try to write this, see what is the output now. Copy this thing. So one hot encoding of x is already given here. So I have a 4 by 4 matrix because there are 4 elements, so 4 columns, and 3 plus 1 equals to 4, so 4 rows. Now I have to perform the one hot encoding thing. Okay, so how do we do that? Okay, now you can actually just pause the video and try by yourself a little bit, think how you can do that, and come up with an algorithm by yourself. That's actually the best approach, but since I am just going to show you here how to do this. Okay, so uh, I am doing it in one way, you can try to do it in another way, that's completely fine. Okay, so what I am going to do is that I am going to write a for loop for, okay, I'll call this iterator variable I is equals to 1 is to this column call. Okay, this is the number of elements in x, so I am going to go column wise. Okay, I'm going to go column wise 1 2 3 4. Okay, so I'll go to, so first from the 1 to column wise. Now what I'm going to do here is that I'm going to define y. First I'll take this first column, so first column should be equals to, what is the row number? The row number is, since this is 3, so the fourth element should be 1. Okay, since it is 1, the second element of that column should be 1, so it is like my x of I x of I plus 1. Okay, so x of I plus 1 means, so for I is equals to 1, the x of I is 3, 3 plus 1 means 4, so I of fourth column first element, so first element means I am going to generalize it with I, so fourth column ith element, my first element is going to become 1, so that is should be equals to 1, so others are already 0, so I have to do nothing about that. So let's take a look at when I becomes 2, so I have x of 2 is equals to koto 1. Okay, so 1 plus 1 equals to 2, that means the second row, and I is equals to 2, second row second column should become 1. Okay, and so on. Okay, so let's see here, let's erase this thing. Okay, it will actually become clear. So if I write something like one hot encoding, let's start with first. So first we had, so x was 3, so this element is actually becoming 1. In the next iteration this is becoming 1, this is 1. In third iteration I want this third 0, so this is actually becoming 1. In the fourth iteration this is actually becoming 1. So I believe it is clear, and there is another example also given here. So x is equals to something like this, so let's put it here. Let's post this one, so 0 0 1 0 3, and if I actually write it, let's suppress this one for now. Okay, suppress this output for now, I don't want to see it again. So one hot encoding of x, so as you can see, since it is 0, that means the first element should be 1 0, so first element is 1 1, so the second element is 1 0, again first element is 1 3, so the third element is equals to 1. So let's actually see another example. Okay, instead of 3 let's make something like 7. So if I make something like 7, now I will have a matrix, and place another one, let's say 2. Okay, so I will have, as you can see, 1 2 3 4 5 6 7, I will have a matrix with 7 columns, but now since the maximum is 7, I will have total 8 rows. Okay, now if I actually write it here, let's increase this first so that I can view it. As you can see, I have total 8 rows, the 7th element is 1. Okay, so sorry, the 8th element in the this column, 8th element is actually 1, and then I need so on. So I hope it is clear. So this is what is called one hot encoding. Okay, and so I believe that there should not be any confusion about this program. This is an easy exercise. Okay, so let's finish this.